Hello guys, welcome to Sumo Code. So today we are going to learn how in Java we can implement multithreading, what multithreading is, how multithreading helps us in optimizing our code, how our codes run faster in if we use multithreading. So all these topics we are going to learn in this video. So before going deep into what multithreading is, let's first look at how multiple programs can execute in a system. So there are three ways. First one is the serial way. In this the programs would be executed serially, like one by one. One program would first come to the CPU, it will execute, then goes out, then another program will come in, will execute fully, then go out. So this is serial execution. Then the other two are concurrent and parallel execution. These two look similar, but they are not. So let's have a deep understanding of what happens when programs run in concurrent and parallel way. So first thing is concurrency and parallelism is not same. So what happens when multiple programs are executed concurrently? So in that case, what happens is that the CPU continuously switches between these programs, and at one point of time, only one program would be executing. So let's see an example. Let me show it with an example here. So consider if this is my CPU, and if I have two tasks, consider A and B. Now for 1 second, consider the program A would be executing. Then after 1 second, program B would be executing and A would be made to wait again. Then after 1 second, consider B would go out of the CPU. Then it will be waiting and then again A would come. Then after 3 second, for 1 second, A would be executing, then B would be executing. So in this manner, the CPU would be context switching between the program A and B, and at a given point of time, only one program would be executing. This context switching happens very fast, and it gives us an illusion that the programs are multiple programs are executing at all at the same time, but actually they are not. Now let's look at what happens when programs are executed parallelly. So it is pure parallelism, like programs would be executing parallelly. This is not an illusion. And parallelism can only be achieved when we have a system where multiple CPUs are there or multiple cores are there. So in those cases, only tasks or the programs can be executed parallelly. So for this, consider that if I have a system, so this is my system, it has two CPUs or core. So this is one core, this is two core, and if I have two tasks A and B, then at one point of time, these, because these are two CPUs, two cores, these can easily, and they have to means execute two programs at the same time. So this is what parallelism. So in parallelism, multiple programs can run at the same time. So this is what parallelism is. So now we know that if we have multiple programs and if we can run it concurrently or parallelly, they can run faster. So if we have our Java program and if we can make it into multiple pieces, it can run faster if we can run it concurrently or parallelly. And that is what multithreading is actually. So what happens in multithreading is that a program or a process or a task would be divided into several some smaller tasks which can run independently. So in a simple definition, all these independent tasks are known as the threads only. And actually what and the bookish definition of thread is threads are lightweight subprocesses. So if we can divide our Java program into these small threads which are independent, so we can run it concurrently or parallelly, and it makes our program to run faster and also makes the CPU to be utilized more. So this is multi-threading. So you may have a doubt that if I have multiple cores in my system, then my Java program would run in concurrent way or parallel way. So this depends upon the OS and the thread scheduler. They decide actually whether the program should be run in a concurrent or a parallel way. And it depends upon various factors in the OS, like what is the priority of the programs and what is the optimized way of running these couple of threads. So all this depends upon this. Now let's see how we can achieve multi-threading in Java. So there are basically three ways to achieve multi-threading or implement multi-threading. So the first one is using a thread class and another one is using a runnable interface. Both of these are similar kind. In the first way, we have to extend to the thread class, and in the second one, we have to just implement the runnable interface. In both of these, we have to create our thread manually, and these are not that much efficient when you are writing a big long code. And one more drawback of using thread and runnable interface is that they do not return anything. You can just pass your task to perform. They would not return anything out of it. So this is the two most basic way how to create threads and use them. So the third way to create a multi-threaded program is to use callable and the future interfaces. So in this, so if you are using callable and the future interface, you can also return values from it. So it helps us in returning values from the threads as well. Also, to use call level and the future interface, you have to use executor service. Executor service gives you an easy way to create and manage a pool of threads. So these threads would be always available, and whenever a task comes for execution to these threads would be picked up, a task would be executed on them, and when the task is executed, the thread would come again to the pool of these threads. And all these threads can be reused as well. So this provides a convenient way to manage the threads. So let's look at all these three ways in action in the code. So let's see our first way how to create threads. So it is using the thread class. Internally, the thread class uses the runnable interface only, which is the second way of how we can create threads. So now I've created this worker thread class of mine, which extends this thread class. And because it extends the thread class, I have to implement the run method as well. And in this run method, I can add my business logic or whatever I want to do in this thread. Also, one more thing to notice here is the return type of this run method is void, because of which we can't return anything out of this thread. Also, if you want to pass some variables to this thread of yours, you can pass using the constructor of this class, which I made. So I can pass the work property here. And in this run method, I have just printed out the work value and also the current thread name. So now let's execute it in our main method. So for this, I would be creating 5 threads, and we will monitor how these threads run. So I've created these 5 threads using this for loop. And also I've started the thread using the start method given by the thread class. Let's run it and see how these threads run. So here you can see these threads do not execute serially. Like first the worker 0 was executed, then 2, then 4, then 1 and 3. So because these tasks are running concurrently or parallelly based on my system's architecture, if I have multiple cores, the order in which these threads are going to be executed can't be said. So if I again run this code, it will have some other order. So here you can see the thread 2 or the worker 2 was executed first. Earlier it was worker 0. Then again, if you'd see now worker 4 is the first one. So the order of execution of these threads can't be said. Now let's look at our second way how to create threads and use them. So the second way is using the runnable interface. It is similar to the thread class one. Here we implement the runnable interface instead of using the class thread. So here again we have to override our run method. It again does not return anything. So and I'm just printing out some values here. So it is similar to the thread example. So to use it again, I'm creating 5 threads using this runnable thread. Also, to execute an runnable thread, you have to create a thread object and then pass the runnable thread object to this thread class, that thread object that you have created. Like this, I will be creating this thread object, new thread. It is an anonymous thread. Then I will be passing my runnable thread object to it and will use my start method to call or start the thread. So now let's start this code and see it in action. Again here, similar to the earlier one, the order of execution can't be set. Let's run it again. Again, see, the order of execution changes. So these two are the example of how you can create threads, and these two ways are not that much widely used, and also they do not return anything from their thread. So to return something from your thread, you have to use the executor service to create your threads and use the futures and the callables. So the most widely used way of creating threads and making your program multi-threaded is using executor service, creating tasks using callables, and getting the return value using the futures. So here, as earlier said, executor service gives you a very convenient way to create your threads, manage them, and also reuse them. It creates a pool of threads. So here in this example, I've created a pool of threads of size 3, and I've created this callable task. So these are my tasks similar to the thread and the runnable interfaces. So here I have to implement the call method. Here, as you can see, they can return any value. Here I have returning string, but you can return anything. You can return a list as well, integer as well. So these using callables, it gives you the power to return some values from your thread. And again, if you want to pass some values to your task, you can use these properties of your class. Here I have created the task name property. And from this call method, I am returning my string with the current thread name. So these are my tasks. Now to execute my task, I have created this for loop and I'm using my executor service to submit this task. So I've created 5 tasks and I'm submitting it to my executor service, which has only 3 threads. So because only 3 threads are there, so some of these threads are going to get reused. Also, to get the values out of this task, we will be using this future. So I've created this list of futures which will contain the futures obtained from this callable tasks. Also, one more thing, when this for loop will run, it will not wait for the callable tasks call method to finish. It will just continue running again, and they will return a future which will be running in some separate threads. Now when this for loops ends, we to get the values out of my futures, we will be using this get method of the future, which will print the values what we have got from our tasks. So let's run it and see the behavior. So here you can see the thread 3 was reused again and again, and my pool was always made of size 3, 1, 2, and 3. Let's run it again. So here, as you can see earlier, thread 3 was reused again. Now thread 2 was reused again. So using this, you can also maintain the order of executions as well. Like, because I was adding my futures to a list, and the list maintains the order. So that's why always task 0, 1, 2, 3, 4 was always in the order it is given. But the thread on which it was executed, those can't be set. So this is all about multi-threading in Java. I have covered all the main concepts that are there in the code as well. So if you have any doubt, please write it down in the comments. If you like this video, please give it a like. Also, please subscribe to my channel. Thank you. Bye.